This video is a review of linear functions. And slope. So, let's just talk about the graph of f of x equals c. And you know, when we say f of x equals c, that's the same as saying like y equals c. Where c is a constant, is a horizontal line. Through C on the y-axis. In other words, you know, when we say y equals c, it's y equals a number. Doesn't matter what x is, right? Y will always be that constant value. So just a quick example here, graphing it. If I was to look at this, I said the graph something like f of x equals 2. Now remember, that's the same as saying the line, you know, y equals 2. And if I was to sketch this out, I'll sketch it on just a little x and y axis I'll draw for ourselves here. You know, here's x, here's y. We will assume these are all 1 apart. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And drawing y equals 2, regardless of what x is, y is 2. So when x is 0, y is 2. When x is 1, y is 2. When x is 2, y is 2, and so on. And you would get this horizontal line. So this is the line f of x equals 2, or the line y equals 2. So if you just have y equals a number, f of x equals a number, it's a constant. It's a horizontal line in terms of a graph. Similar but different. The graph of x equals a, where a is a constant, is a vertical line through a on the x-axis. So again, when we were looking at this, you know, it doesn't matter what y is in this case, right? X is always going to be equal to the value of a, that constant value. So we'll just do another quick example here. So if I said to graph, and we'll use x equals -3 as our example. I could draw an x and y axis here. Here's x, here's y. 1, 2, 3, 4, 1, 2, 3, 4. We'll assume all those are 1 apart again. When x equals -3, it doesn't matter what y is, x is -3. So x is -3, there's -3, 0, -3, 1, -3, 2, -3, 3, and so on. It ends up being this vertical line straight up and down through -3. So yeah, x equals -3. Quick thing to note here, this is not a function. Remember, to be a function, for every x value there only can be one y value. It has to pass the vertical line test. This does not pass the vertical line test, because if I draw a vertical line through this line, it hits at more than one point. So we have x equals a number, right? X equals a constant. It's not a function. But for y equals a constant, it is a function, right? Up here, every x value only has one y value. It passes the vertical line test. Let's talk about slope a little bit here. So the slope of a line going through the points x1, y1 and x2, y2. So these are ordered pairs, these are placeholders, right? x1 goes along with y1, x2 goes along with y2. These are going to be actual values. Is given by, and we have a slope formula. The slope, the letter we use for it is m, and it's equal to y2 minus y1, the change in the y values, over x2 minus x1, the change in the x values. So that's our slope formula. You likely have seen it before. You know, interchangeably, how I said it in words, right? I said change in y over change in x. Sometimes you might see change in represented as this delta y over delta x, right? These all mean the same thing. So make sure you understand that, right? The slope is a change in y over change in x. It's important that you're consistent with, you know, if you start with y2 minus y1, then the denominator you do x2 minus x1, keeping the order the same between the coordinates. A quick little drawing of what this would look like on an axis. This is an x-axis and this is a y-axis. When I say I have the point x1, y1, I'll just label it here. So I'll say that's x1, y1. And the other point I have, I'll label x2, y2. So these are values. You know, we're just using them generally. So here's x2, y2. I'm talking about a line that goes through those points. Well, if I want to find the slope of this line, right, really it comes from the change in the y values. Really, it's the difference here. So when I'm talking about the slope, I'm talking about how it moves from one point to get to the other point. Well, what's this change in y? How do you find this distance? Well, if these are numbers, to find the distance between them, you subtract from the larger number, right? Like if this was 5 is y2 and this was 3 is y1, you would do 5 minus 3. Since I don't know what these values are, generally it's just y2 minus y1. And that would be this space right here. So for my slope, the numerator comes from that change in y, y2 minus y1. For my denominator, the change in x, so I'm talking about how do I go up from here to here, right? So I went up that many units. How do I figure out how many units they are from left to right? Well, what's the difference between these points? Again, you're subtracting. This would be x2 minus x1, the larger one, take away the smaller one, right? If this was 5 and this was 3, you would say 5 minus 3 gives me that distance of 2. So the slope, you know, that's really where we're getting it from. It's a change in y over change in x. Sometimes you hear people call this, you know, the rise over the run. However you remember it, make sure you know the slope formula, though. It's going to be very important. Taking a look at another example, you know, using this. If I said, find the slope between -4, 5 and 6, -2. It should seem fairly straightforward. You're going to use the slope formula, and we know the formula from above, right? We'll just write it out. So slope m is equal to y2 minus y1 over x2 minus x1. I'm going to label these coordinates x1, y1, x2, y2. Make sure x1 always goes with y1, x2 always goes with y2. They have to be x and then y in that order, because that's the order that we write our coordinates. And then substituting into here, well, we got y2 minus y1. According to how I labeled it, it'd be -2 minus 5 over x2 minus x1 would be 6 minus, because that's the formula, and we're subtracting off a negative 4. So it's minus a negative 4. Make sure you see this. The first negative is from the formula. X1 is a negative 4, so you make sure you have two negatives there. And negative 2 minus 5 is negative 7 over 6 minus a negative 4 really is the same as saying 6 plus 4. So that gives us 10. Negative 7 over 10. If it doesn't reduce, we'll leave it as negative 7/10. In an application problem, you might need to be asked to use that as a decimal. If not, we'll leave it in exact form as negative 7/10 as a fraction. If you did give me a decimal and I didn't ask you specifically, I'd be okay with you giving a decimal, but you'll see it frequently as a fraction. The only other thing to point out is if you labeled the points as this one being x2, y2, and this one being x1, y1, you would have gotten the same answer. It would have been 7 over negative 10. Remember, a negative in a fraction can be written in the numerator, the denominator right out in front. They're all equivalent, but you don't put two negative signs in there. All right, let's talk about a linear function. So a linear function is given by, and since we're talking about functions here, I'll write it as f of x. Right, remember f of x is the same as saying y. F of x equals mx plus b, where, remember I said f of x, you could say is y equals mx plus b. You've probably seen this form before, where m is your slope, whatever's in front of x, in other words, is your slope, and where the coordinate 0 comma b is the y-intercept. Remember, x is going to stay x. Really, y and x stay y and x in these. All right, and this is called the slope-intercept form. And because this is a review, you should be familiar with this already. You probably have seen it as y equals mx plus b. Remember, y and f of x are interchangeable. So this is the slope-intercept form of a line. The other form of a line that we use, and especially more frequently in calculus we use it, is the point-slope form. So the point-slope form of a line with slope m and going through the point x1, y1 is given by the equation. Now, when I say is given by the equation here, this x1, y1 is just a point you know, m is a slope you know, and you still need a y and an x, just like you did in the form above. But the way we write it is we say we have y minus y1 equals m times in parentheses x minus x1. When I do this, right, the x1, y1 are the point you know, m is the slope, the y and the x are going to stay y and x. So it's giving you another form of the line. The reason this is important, though, is that now you can come up with the equation of a line if you are just given one of the points and you know the slope. So that gives us a lot more versatility than the other form that we had. And oftentimes in calculus, what's going to happen is you'll be talking about finding the slope and then using it to find the equation of this line. Let's take a look at an example here. So for this example, if I said to find the equation of the line going through the point -2, 6. And having slope of 1/2. So when we take a look at this example here, first off, you should notice that they gave you a point and they gave you a slope. So that indicates that you should probably try using this point slope form. That's why it's called point slope form, right? You just need a point and a slope. So let's write out the equation. The equation I would be using, we would have y minus y1 equals m times, in parentheses, x minus x1. You need those parentheses. And remember what I said, the y and the x are going to stay y and x. You need those because that's going to give us what our function really turns out to be. So you have y minus y1. Well, y1, remember this is our point x1, y1. So y1 is 6. So y minus 6 equals m. They told us the slope. M is 1/2, right? So make sure you know that's where m is coming from. Times, in parentheses, x, remember, stays x minus x1. x1 is a -2, so it's minus a -2 here. Make sure the first negative is from the formula, the second one is from the actual coordinate. Once you have this, let's simplify it. You have y minus 6 equals, this is 1/2 times x minus a negative makes this plus 2. And if you have this formula line, this is the line in point slope form. Typically, though, they're going to ask you to give us the answer in slope-intercept form. So you found the point slope form. We're right here, right? So you found the point slope form right there. To get to the slope-intercept form, to get to the y equals mx plus b form, like we had way at the top here, what you're really going to do is just solve this for y. So to solve this for y, I'll distribute the 1/2 through first. So I end up with y minus 6 equals 1/2 times x is 1/2 x. Make sure x is either right next to it or in the numerator. It's not in the denominator. 1/2 times 2, well, that'll be plus 1/2 times 2 is really, if you want to multiply, is 2 times 1 divided by 2, which just gives you 1, right? 1/2 times 2 is 1. And then to solve this for y, all you do is add 6 to each side to isolate y on the left. Adding 6 to each side ends with y equals 1/2 x plus 1 plus 6 is plus 7. And that's going to be the equation in slope-intercept form. So you have the slope-intercept form. You also have the point-slope form. Typically, we use the point-slope form to get to the slope-intercept form. You might also see this written as a function. If I said define this as a function, remember y and f of x are interchangeable. You could just call this f of x equals 1/2 x plus 7. That's the function notation. Let's take a look at just a couple applications of slope here. So when I say applications of slope, keep in mind that it might be disguised in other words. They might not actually stay slope, right? So this is applications of slope. You know, other terms you might hear used, right? So other terms used for slope include something like the grade. Sometimes they'll say the grade of a ramp, the grade of a road. Say grade of a road. A lot of times you'll see usually this as a percent if we're talking about the grade. The pitch, like of a roof. Really talking about the slope. You might hear just slope, right? Slope of a ramp. And the last way that I'm going to talk about, and this is the one that is used most often in calculus, is the average rate of change. So all of these mean slope. So if you hear those words in a problem, that's telling you you need to find the slope. So we'll just do a few examples. If I said find the grade of the ramp shown. So suppose, you know, I have this ramp going up to, some sort of building here. And so this ramp here is going up to the building, and this kind of meets at a right angle here. But if I told you that this length here for the ramp was 18 feet, here's I'm giving you that information. And I'm telling you the height here, we'll say, is 6 feet, right? So that's the height of the ramp. So if I'm looking for the grade here, what it's really asking me to do is asking me to find the slope. So to find the slope, you know, it doesn't give you points, right? But we do know that the slope is equal to our change in y over change in x. If you need to, you could make a coordinate here. You could call this point 0, 0, and then how far over and how far up is that? Well, this point would be an x value of 18 and a y value of 6. But it's easier than that. You can just kind of look at what you have, right? So what's the change in y? How high is this ramp? Well, it's 6 feet high, so then that would be 6 over what's the change in x? Well, change in x is 18 feet. And you want to simplify that. Well, 6 over 18 as a fraction reduces down to 1/3. And then, because I said earlier, you typically want to write this, because it says grade, as a percent. As a percentage, remember, 1/3 is really as a decimal, approximately 0.333, right? It goes on forever, 3 repeating. So as a percentage, we'll just round it to 1 decimal place. So I'll say 33.3%. So that's how I would talk about the grade there. The last way we'll talk about it is just doing an example with the average rate of change, because I think it's helpful. So let's write out our slope definition, but using average rate of change, and then we'll talk about how to actually, do an example using it. So the average rate of change Alright, so the average rate of change of the function y equals f of x between x equals a and x equals b is, now when I say this, right, first off, average rate of change, I already indicated it, but it really is saying find the slope. A and b are going to be constants, right? They're going to be real number values. When I say y equals f of x, all I'm saying is that, there's a function, y and f of x are used interchangeably, but it really gives you information about how to find coordinates for the points. Because if the x value is a, the y value that goes with it is called f of a. And if the x value is called b, then the y value that goes with it is called f of b. Now, typically this will have a number, but because we're talking about this generally, we're just going to call them f of a and f of b. But all that really means is the y value that goes with a, this means the y value that goes with b. So, doing that, we're going to follow our slope formula, right? So, if I say the average rate of change, by the way, average is very important here. If it says instantaneous, that means something else, right? So average rate of change, well, that's equal to the slope we said, which was equal to, remember how we did it. We said y2 minus y1 over x2 minus x1. Here I'm going to call this x1, y1. I'll call this one down here x2, y2. So if I'm doing y2 minus y1, I'm really saying f of b minus f of a over x2 minus x1 would be b minus a, right? So y2 minus y1 over x2 minus x1. So the average rate of change is the slope. It's a change in y over change in x. You just have to come up with the points in terms of the function, but it works the same way. So let's take a look at an example just using this. All right, it's no different than finding slope. When you hear average rate of change, that's really what it's telling you to do. So I'm going to give you a graph here. So if I said given the graph, and I'm going to sketch it out. So it's going to have to do with the cost of a wedding. So if I draw this graph here, it's going to have an x-axis and a y-axis, and I'm going to have, you know, some line going through it, and the y-axis is going to represent cost of a wedding, right? And I'll say in dollars. And the x-axis will be in years. And I'm going to put some labels on here just so you can kind of see where things fall. So I'll say that tick mark will be 15,000. This one will be 20,000, 25,000, and 30,000. We won't use these directly, just to give us kind of a gauge. And then let's say in 1990, I told you that this was at, actually I should put more over there. In 1990, this is at a point of 1990, comma, 15,208. Right, so it's not exactly on that tick mark, right? It's somewhere in between. And then I said in the year 2005, we're looking somewhere over here. In the year 2005, we'll say that that point has coordinates 2005, comma, 26,327. So I'm giving you this graph. You know, it'll be more accurate when you see it, you know, in a textbook or in an online homework assignment. But the point being is they're giving you 2 points on this line. They're telling you about the cost of a wedding in dollars versus X, which is the number of years. So what this really tells you is that in 1990, right, the cost for the wedding was $15,208. But in 2005, right, the cost of the wedding would be $26,327. So I didn't ask you a question yet, right? I just gave you a picture. But the question is going to ask us to find the average rate of change for cost of a wedding between 1990 and 2005. So the question actually isn't that difficult, and I didn't even have to show you this picture. I could have just given you the ordered pairs, right? I didn't have to actually draw this out. Average rate of change, that's telling you right away, you should notice, find the slope. That's all it's asking you to do. Now, when I'm looking for the slope between 2 points, I could have just told you in words. The average cost, or the cost of a wedding in 1990 was $15,208. In 2005, the cost of a wedding was $26,327. Find the average rate of change for cost of a wedding between 1990 and 2005. That's the same question, right? I just didn't write it all in words. So to find the slope here, how does it work? Change in y over change in x. Well, change in y, looking at this, y2 minus y1, we'll have 26,327 minus 15,208 over the change in x, 2005, right? That's the x2 minus x1 would be 1990. And we're just going to evaluate this. So 26,327 minus 15,208, that comes to 11,119 over 2005 minus 1990. Well, that's just 15. So we want to divide this out because it's going to give us information. So, you know, you want to do 11,119 divided by 15. And what I get on my calculator, you can see it there, we have 741 dollars, and since this is money, 0.26 will round, that 6 moves up to 0.27 because it's 0.266, so that rounds up to 7. And make sure you know the units. The units for slope are actually easier to figure out than you might think. It's always the units of y over the units of x, right? So whatever's in the numerator, change in y, well, that was in dollars, so this is dollars per what? Well, per x, which is dollars per year. You could write the word per there, or you could write it over years, right? Or you could write 741.27 and write the word dollars per year. Making sure you understand the units, though. So the units are dollars per year. Now you should write a sentence kind of to make sure that you understand this, right? So this tells us the average cost of a wedding. Now, because this is positive, it's telling you it's going up. You can see it from the picture, but in case you didn't have the picture, the slope being positive tells you it's increasing. The slope was negative, it tells you it's decreasing. So the average cost of a wedding increased. You want to say that word. That's telling me that you're analyzing that slope properly. You know, it's positive, tells you it's increasing, right? So it's increased by a rate of $741.27 per year between 1990 in 2005. It's very specific to that interval. You can't talk about things that happened after that or before it. Remember, this is the average rate of change of the cost, right? Meaning that, you know, in the years in between, didn't have to go up by $741.27 per year. In this case, it looks like it because the graph is linear, but if the graph wasn't a straight line, you know, that cost could be everywhere. But on average, that's how much it would go up by. So hopefully this helped with understanding slope and you know, understanding where the point slope formula line comes from and how we'll be using it later in the course.